Naomi, and I worked on part 1 of the stenography project.
Hi, I'm Rongke. I worked on part 2 of that.
And I'm Rick, and I worked on the recovery method. Also,
we worked on the GUI together.
Yeah.
So I worked on first flattening the image. So I take the image that we want to flatten, and I change half of the numbers to zeros, and the other half I change to ones. And then I save that to BW image. And it works with the expand function, where the expand takes the BW image and it makes it into a black and white image using color map gray.
So now I'm gonna explain the embedding functions. There are 10 embedding functions, and I'm gonna go over one and then briefly go over others because they are kind of similar. And so now this is the first one. It's called binary 1 red embed. I have 2 input variables. The first one is the hidden image that we need to hide, and the second image is the original image that we need to hide the first image in. And the output is gonna be the image with the hidden image. Okay, so the first step is to convert the numbers in the red channels of all the pixels of the original image into binary form. And when I do that, it's gonna give me back a string of 8 characters. It's gonna be binary. And so I'm gonna take the last digit, which is the last character of the string, and change it into a digit, a number, and then store it into a variable named red1digit. Also, I need to flatten the chosen image, so I use the flattening function that is written by Naomi, and here I name the output of the flattening function flat chosen image. So next step, I'm gonna use logical indexing, and because the flatten function gives me back 0 if the pixel is black in the hidden image, and it gives me back 1 if the pixel is white in the hidden image, I'm gonna change the corresponding red first digit in the corresponding pixels into 1 or 0 if the flattened chosen image has 1 or 0 in it. So here is the block of the code I'm talking about. After that, I'm gonna make the red first digit back to the image that I want to print out. So I'm gonna change it back to character, and then replace the last character of the string, of the binary string, with this character. And then I put this binary string back to decimal. And then I can replace all the things in the output image. And then I have to reshape it because as I mentioned before, the binary thing is gonna make it into linear indexing. It's gonna be linear matrix, and I need to reshape it so it fits into that 400 times 400 pixels. So this is the end of the first embedding function. And then for the other 9s, as I said, this is to change the first binary digit of the red channel, and then it's gonna be the second digit of the red channel, and the third digit, and the fourth digit. And for the other 2 channels, I did similar things, but since we only need 10 functions, I only did 3 digits for the other 2 channels, and these are the embedding functions I have.
Alrighty, hey there guys, we're going to start moving on to the recovery section. This function here is called binary 1 red recovery, which coincides with RK's binary 1 red embed. And here what we're doing is we're taking an image as the input, which is RK's output, and I'm going to be converting it to get the hidden image out of the function. And by doing so, I'm going to create this recovered matrix of zeros. That's a 400 by 400, and I need to create that as placeholders for my upcoming values. And I also have this image is equal to image indexing, and the one here is for the red channel, as you guys know. So we're just focusing on the red channel, hence red recovery. And then here we have the decimal to binary. And decimal to binary gives you a linear array. So we also needed to get the size in order to reshape it later on in the code. But we'll get to that. So I did a for loop from 1 to the length of bin image, which is the binary image that I created here. And in that for loop, I created an if statement saying if the binary image I end, since it is binary, it's going to index them as characters. If the last binary bit equals 0, I'm going to make it a black pixel. And if it's not a 0, it goes to the else statement, which makes it a 1, and that's going to make it white. And in doing so, I'm doing it for the full length, which is 160,000 indices. And then I'm going to get the recovered matrix and reshape it down here with the image size I have earlier to get hidden image, which will be called later in the GUI. Now, this is the binary 1 red recovery. We also have the binary 1 green and binary 1 blue. It's just changing through the color channels. Then we have the binary 2, binary 3 recoveries, which is just changing the binary it's changing the bits we're working with in the binary code.
I worked on putting all of the functions into our GUI program. Here is where we first call our original image, and it allows the user to save or to choose an image from their computer using this, and it assigns that image to file name 1 and path name 1. And once they click the push button, it shows the image. It is a global variable so that we are able to use the original image in other functions within our GUI. This is the push button 2 for loading the image they wish to conceal into the original image. So this is for the hidden image. And the hidden image we'll call file name 2 and path name 2. And that's also going to be a global variable. And once they push the button, it will show the hidden image. Here is where we use the embedded function that RK worked on. It takes the hidden image that we saved into the global variable right here, and it changes it so it makes it I'm red, so we can now use these to work with the hidden image. So then we use the function and we assign it to embedded image, and then we show the image. And that's pretty much the same for all the embedding functions.
And then we'll go on to embedding more hidden images. So we'll start off by loading the original image, which is the dog image.png. We'll load a hidden image. We will load hidden image 2, because why not? Then we'll do binary 1 red embed. We will save that embedded image as binary. We'll just write over the last one that says binary. And then in order for us to put another hidden image in, we're going to reload the image we just saved. So we'll go to binary. It's loaded. We'll pick a new image. Since this was 2, we'll go down to 5. Then we'll do the next one over, binary 1 green embed. It is now embedded. We will save the embedded image. We will save it as binary just to rewrite over it. Then we will go back one more time, just to show you guys you can do it as many times as we want. We'll go to load original image. We'll do binary again, since we replaced it. We will load a new hidden image. And we did 2 and 5, so this time we will do 4. Alrighty, and then we'll do binary 4 red embed at the very bottom to switch it up. Alright, and then we'll save it as binary to overwrite the last binary. We will replace it. And we'll move on to the recovery stage where we load the embedded image. And we have the binary as our embedded image. And we know we have the evil villain, which is in the binary 4 red recovery. So we'll click that. We do get her. We also have the hidden image 5, which is evil villain Jamarcus. And he's going to be in binary 1 green recovery. There he is, evil Jamarcus. And for the last one, we'll go over to hidden image 2. And that'll be in binary 1 red recovery. And there it is. And to reset it all, just to show you it works, there you go. And that is our GUI demonstration.